Welcome to the lecture number 23 in the peer-to-peer MOOC series. In this lecture, we will be focusing on peer-to-peer mailing system. So we all know that how the email actually works, that normally you are going to sit on your computer, you will log on to a terminal. Either you will be connecting either through a web browser to a mail client, or you will be running a client on your machine, say for example Thunderbird. Same thing which you do on your mobile phone. So there is a mail client which is installed. So for Android phones, popularly it's a Gmail client which is used. So, but it's a program which is running on your machine itself, and this talks to a server. Okay. So, but the idea is that A can write a message, and this message can be then transported to B. And we have a unique identifier being assigned to A and B. So you can actually send a message to anybody. So this will just propagate through the network and reach to everyone. Okay. So if you want to do this in a peer-to-peer system, important thing is that A should know what is the endpoint address of B. Similarly, B should also know that what is the endpoint address of A. In fact, it is easier if A finds the endpoint address of B, and when it is going to communicate to B, B will anyway figure out what's the endpoint address of A, because A has communicated. They need to also do a mutual authentication so that B recognizes that this is A and A recognizes who is B. Okay. And they can always transfer the message from one to another. So that can always be done. And because we are actually using certificates for A and B, so A can actually digitally sign the message and send it to B. So B knows it has been sent by A. They anyway have done a mutual authentication. So whatever messages are being transacted, they know who is sending the message, and A knows who is receiving the message. They need not even digitally sign in this case. Okay. So, but when they both need to be alive in this case, the important thing that both need to be alive. So both are there in the network at the same time, so they can talk to each other and then they can pass on the message. But normally when I am sending message, I just want my system, I want to just hand over the message to somebody even if the other endpoint is off. And whenever that person comes alive, he will get my message and he knows what I communicated actually. That's ideally the way the mailing systems actually work. So now the question which remains with us is, the problem which we have to face if I want to build up a peer-to-peer system is, if A or B is down, how the messages will be sent or received. So if B is down, A should be able to send the message, and when A is down, B still should be able to receive the message if it was dispatched. So there may be a time offset, so A and B need not be on at the same time. Okay. So maybe what we can do is that A can, when B is off, A can send it to some other peer. So we call it C, and B is off as of now. Okay, so I can call it this and off. And next time when A is off, so the message can be retrieved from C by B when B comes alive. Okay, this could be a potential way of solving the problem. So we can actually use some intermediary which can act as a message storage. So even when A and B are off, we should be able to send. That's a property, that's a desirable thing whenever a mail system needs to be implemented. Okay, so first thing, irrespective of destination being off, one should be able to send a mail. And of course, similarly, irrespective of source being off, one should be able to receive the mail. So, and of course, this was this one first criterion. Secondly, I would like to always send the attachments. We actually send attachments through mails. We can send documents. Okay, so I should be able to send the attachments. That property also should be there when I create a peer-to-peer mailing system. In this case, when both A and B are alive, A can send the message, it can transact even all the files, whatever attachments it wants, with the mail to B, and B can interpret that. But the problem happens in this kind of scenario. Okay, here also we need to provide a mechanism. But whenever I use some intermediary in a mailing system, normally we depend on the mail servers, and mail servers we assume are going to be operated by operators. Though actually they can see the mail, what's there inside the content of it, but we normally assume there is no third party except the operators who are actually can look at the mail. So there is some kind of rudimentary security which is there. But here these intermediaries can be any user's node, actually any user's machine. So I need security. So except the destination, nobody should be able to see what is there, what is the content. So we need to provide a mechanism for this. And of course, whenever this kind of thing is there, when I am retrieving the message, I should be sure that who the sender was and genuineness of the sender. It should not be a fake mail. Okay. So receiver should be able to verify. Receiver should be able to verify the sender of email. So that is the important. These are basically the characteristics which are required in any mailing system. So we in fact require, even the current existing mailing system don't satisfy this criterion unless you encrypt the mails, or you are using some kind of a what we call public certificates being installed in your mail clients. So if you install a certificate, then it is possible that you can digitally sign the mails. You can receive the mails encrypted. So, but you can't send the mail to somebody else as encrypted mail unless you have the other person's certificate with you. So this is already there, available in most of the mail clients. But now you mostly depend on the operator for this particular purpose. Okay. So we call this particular property one is non-repudiation. If somebody sends me email, so that other guy should not be able to say that I have never sent this email. This is a fake email. You should be able to prove it was indeed sent by him. That's a non-repudiation property, and the secrecy means nobody should be able to see this. These two properties are essential. So current day system, this can be done to an extent by digital signatures and by using public certificates. The certificate, the public key which is there inside the certificate, using that you can do the encryption when you are sending a mail to a receiver. Okay, so now let's look at how the existing system actually operates, and from there we will figure out how we have to actually handle things. So currently emails are normally being always of this form. You will always have user ID at the rate some domain name. Okay, so domain name, for example, for my mail ID, domain name is going to be iitk .ac.in, and whatever is my mail ID. So this is my mail ID which is going to be there. Okay, so this is the way we actually figure out. Now important thing, when somebody wants to send a mail to me, to which machine the mail should be sent, how that is identified. Now important thing is this particular domain. So this actually comes from DNS. So DNS stands for domain name service. Okay, so the way it happens is throughout the world. So in fact there is a dot which should come here. So if you look at this dot, this is also a domain and we call it a root. So throughout the world there are few servers which are the root servers. So whenever you want to find out what's an IP address for this, so this will always go to that root server. So the information about this means actually you have to go to that root server. So root domain, so there is a corresponding root servers. So these mostly comes in hard coded inside your machine. So whenever you do the operating system update on Windows or on Linux, these things entries get updated there. They anyway are fixed entries. They are run across globally. Now what happens is now we actually create a .com domain. So .com domain is actually registered in all these root domains. So all these servers will be maintaining entry for .com. So .com domain is the responsibility of another server. We call it domain server. So this is a domain server for the root domain. So for .com server there is going to be a domain server. So these root domains will be maintaining an entry for .com, and they will say for this you have to go to this particular IP address. So there is an IP address for this domain server is going to be retained. Okay. So once this particular IP address is for this particular machine which is acting as a domain server for .com. Now you want to now start say google.com. So what Google does, Google actually has gone to the .com registrar, so this server which is being owned by a registrar, and said you can create an entry for me. So this guy has must created an entry for google.com and says this is going to be the IP address for that. So basically what it is saying, the name server for this is going to be this IP address. There is a name server entry which is going to be created here. Okay, this is the name server entry which is being created. So there are many entries which are possible. So I am not going to go into details of DNS. So this name server entry, once Google gets created, so Google actually has this particular machine with this IP address. So whenever Google actually going to change this machine, if for example Google changes this IP address, it has to go to again this registrar of .com and make a change here. But anything which is inside the Google, okay, so for example you have some mail.google.com. For this Google need not go to this registrar, it is already having a registrar for google.com. So here it will now maintain an entry which will say mail.google.com, and then it can actually give the address, IP address for this. So we call this as A entry actually. Okay. And similarly I can also create this is A entry, A type A. There is also an entry called PTR, pointer. So here IP address is being put, and you can actually have what's the corresponding domain name. So this is used for reverse domain entries for mapping those. Okay. So this is how the way the domains actually work. So now remember, whenever iitkey.ac.in is a domain, so the server for this actually is running in IIT Kanpur. So we are running a name server. So but where actually this entry will be known to you. So what we have done is IIT Kanpur has gone to a registrar for .ac.in domain. So which in our case is going to be ERNet India. So this organization maintains a server which is the domain for .ac. So anybody who wants to get a subdomain in .ac.in, he has to go here and they will make an entry. So they have actually created an entry for a name server which is running with IIT Kanpur. Okay. So IIT Kanpur can actually have various kind of machines. So we have machines like kasit.iitk.ac.in. We have MMTP. So we have actually created these entries in our name server, in IITK name server. We have not gone to the ERNet India. Only for iitk.ac.in we got an entry done. Any further entries I can do it. If within this, similarly we actually created then subdomain entries for the cc.iitk.ac.in, which is a computer center. We have an entry for e.iitk.ac.in. And we do run a DNS server in electrical engineering also, so I can actually further create machine names here. So for this domain, so whenever you want to send a mail to me, you will, for example, you are in some other domain, you are in say mit.edu domain and you want to send a mail to me. So you are abc@. So whenever your mail client sees this, he has to figure out that where is this iitk.ac.in exists. So he will go to the root server because he does not have an entry for, I think it only knows about what are the, this DNS for mit.edu only knows about what are the hosts inside MIT. And it might have cached some entries which it might have queried while sending the earlier mails. So if no mail has come to iitk.ac.in, so it may not be having the cached entry also. So to go to the root server, we'll say which is where is the .in DNS server. So it will then go to the .in DNS server and will ask him where is .ac.in server. So ERNet India will reply him. Will actually the DNS of ERNet India will reach to him. Then it will ask from ERNet India DNS where is iitk.ac.in. So our DNS entry will become available to them, and then they can actually ask, because mail has to come here, there is something called MX record. Okay, mail exchange record. So it will ask what is the MX entry for this particular domain. So IIT Kanpur domain will now give a IP address of the mail SMTP server which we are running, on which we receive the mails. Okay, so once that entry is available here, this mail client will then, or the SMTP server of this particular MIT will then talk to our SMTP server, which is identified by this, and will pass the message on to him. But now can somebody else also can spoof, can take up that IP address. Okay, so somebody can, for example, change in IITK DNS. So unless IITK DNS need to maintain both the entries. Okay, so it will maintain the entry from IP address to the domain name and then domain name to the IP address both. So both should be verifiable. For this we call it a reverse zone actually entry mapping. The reverse zone verification, once it is done, so then mail can be handed over to me. So technically your mail client will talk to your SMTP server. Your SMTP server will then talk to the SMTP server of the destination, and from there it will be either giving to the IMAP server, there is another server, and my mail client will synchronize with this for receiving the mails. This is my mail client. For sending the mail, I will be sending it to my SMTP server here, which in turn will find out whichever is the destination. So if it has to give a reply back to you, it will give a reply here, which in turn will become available to your IMAP server, and you can fetch the things from here. IMAP is Internet Message Access Protocol. This one is SMTP. This is simple mail transfer protocol. So SMTP is also used here, but they do verifications of each other by using reverse zone entries. Okay, that's typically the way that things actually work. So DNS plays a very important role. It tells which is the entry which is to whom I need to hand over the mail. So in fact, when this mail handover is done, along with this all attachments, everything is actually passed. So normally the attachment limits are there. That depends on your own SMTP server. For IIT Kanpur, for example, I can send a mail up till 20 MB. Okay, Google provides a different limit. So different mail servers can have different limits. So once the mail is received me, it will come to my IMAP thing, and from there my mail client will actually fetch everything and I can read what is there in the mail. Now there is no way I can verify it actually has come from here. So one way of doing it is, if this guy knows my certificate, it will actually encrypt the whole mail and then encrypt the key with my public key. Okay, and that will become part of the header, and this mail will come, so nobody can see in between. When it reaches to me, I have the private key, so I will decrypt the whole mail and I can see it. So in Thunderbird, actually we can do this and we can use it. We in fact can even create our own public private key pair, okay, and use that. Okay, so non-repudiation actually is not built by design into the system. This has to be overlaid on top of it. So this is something which we do. Now there is one more thing which we do in mailing system is we call mailing lists. So I will be talking about both the implementations in peer-to-peer fashion. So what are the mailing lists? For example, in IIT Kanpur, when a director wants to send mail to all the people on the campus, which includes the students, faculty, everybody. So he can't actually remember all the email IDs of everybody, or the 30,000 email IDs he can't remember. So what he does, he sends a mail to all at the rate. Now I am writing a separate DNS. This actually does exist in IITK, list.iitk.ac.in. Okay. So this is a machine which is running separately, and this is going to have a what we call list server. So this is maintained by Computer Center, and they put everybody, all 13,000 email IDs are listed in a database here. They not only maintain all lists, they also maintain many other lists. They maintain a faculty, they maintain academic staff, is academic staff short form for that. This almost similar list, we have students, PG students, all kind of lists. Even faculty has got created their smaller mailing list in this. But the important thing is that when a mail, this is actually acting like a client, this actually gets the mail from director and it is being fetched by the IMAP server, and once the mail comes here, it starts processing the mail. It figures out what's this destination, and then it will look into this basically a separate domain. So technically this SMTP server passes the mail to this list.iitk.ac.in, and then it will start processing depending on what's there in this user ID part. And then if it is all, it will then create a copy of mail for every user, all 13,000 copies which are made. Now this is a cumbersome process. So every time you fire a mail, it takes some time before it reaches to everybody. So if you want a countrywide mailing list, this actually is an exhaustive task to be done. But we do use it, and these 30,000 mails are then being sent back by this machine to this place and SMTP server to everybody. So there is a one copy goes in everybody's mailbox. So IMAP actually create a separate mailbox for every user. So every user there is a file. So that 13,000 accounts or 13,000 copies are going to be done here. Okay. There are of course ingenious ways of doing it. If there is a universal content is not being digitally signed or encrypted, in that case we can create only one copy and people can refer to that actually. That also can be done. Okay, but this is what is a listserv. So we also need to create this listserv also in a peer-to-peer mailing system. Okay, so normally mailing and lists both are actually always go hand in hand. Now, before going to the mailing list implementation, let's talk about how the mail actually will be transferred. So now we are going to do away with this particular system. We don't require IMAP or SMTP server. We don't want this. But one thing is sure, when first time you are going to actually have a certificate being generated, you have to receive a mail, and so your client will be talking to a server which will give us a certificate. So certificate signed by this guy will be accepted by everybody. That's our assumption. So you get an identity. So you don't have to just go there and get a certificate maybe once in 2 years if the certificate is valid for 2 years. Or if you lose your keys, private key, then of course you have to go back and get another certificate for you. Okay. So when you go here, you actually tell your email ID and everything. You tell your public private key pair which you generated. You generate a certificate. The certificate goes here. This guy has to sign and send it back. But this also reads in your certificate what's your email ID. It actually sends an email through this conventional system. You receive that OTP, you put it in, send it back, so there is a confirmation, then it actually signs the certificate and comes back. So now your email ID is part of a certificate. Okay, so after this guy is no more required, the certification authority, okay, or authentication server I call it in Brihaspati 4 term, this will no more be required after this. Okay, so now this user has an email ID, this has a certificate with email ID which is signed by the authentication server. Okay, and now it has to talk to some guy, he has to send a mail to some B. And as I told, because they both may not be alive at the same time, we need to have a mechanism by which they can dispatch, send the mail to somebody which can be then taken up by you. We require something called mail storage. Okay. Now important thing here is, so this mail storage, and if you look at the DFS, we have done DFS earlier, a distributed file system. In that case, files are stored and they are being replenished or they are being moved around the root, but it's not a transient storage. In this case, A will send a message to C and it will be just held up with C till B receives the message. The moment B retrieves the message, this message can be removed from C. So it's only a transient storage. It's not a storage of that kind which was required in file system. Okay, where we create a separate storage DST. So for this, we actually thought of carefully in B4 and B4 Brihaspati 4 design. We have now separated. We have created a separate DST layer for mail storage. We call it a mail storage DST layer. So some nodes will be participating and they will have some storage. Okay. So, and of course, you can be, if you are actually want to send a mail, so this can be part of this DST which is running, mail storage DST, or it can be a leaf node. Okay, if it is a leaf node, it will be telling, because you don't need to put user ID and node ID will be in the base DST. You don't require to put that thing here. Okay, but if, for example, it want to send a mail to B, B is off. So A will search for, so A will now going to search for B in B's node ID. So A will now search for B's node ID in the base DST, in the base layer. Of course, now we are assuming that a user, these are users, A is a user, remember it's not a node ID, B is also a user, it's not a node ID. And node A, user A can actually connect on his mobile phone, can connect on the laptop, can connect on another mobile phone. So he actually can run multiple node IDs. So every time he is actually using this, he can actually submit A to node ID mapping, which can be signed by the private key of A and the private key of the node ID. Node ID, remember, is a public key part. So it will be, there will be two signatures. So one is signed by A, one is signed by node, and this is what is going to be pushed into the base layer. So B's information is also available in the same fashion. So what A will do is, A will now find out, in fact, A will now first of all go to the base layer, send a query about B. So the query will go and it will go to somebody where the one of the nodes where the B's which is the root of hash of B's mail ID. And of course, we will be having copy 1 and copy 2. So copy 1 you can search. There will also be copy 1. Reason being why we do it, because there are now two root nodes and they will be keep on publishing, they will be monitoring each other. So if this guy is monitoring the copy 2 and this guy is monitoring here, so if this guy dies off, this guy immediately republishes it and copy 1 comes alive again, which in turn start monitoring back to this thing. So this repairing can actually happen. There is always somebody which is going to have B's email ID's information. So there at this node, this information about what are the node IDs, so all devices all list of all devices will be available there. So A can retrieve all the node IDs from there corresponding to B. And once this actually has this, what it will do is it will now talk to each one of those node IDs one by one. So A will talk to B's node ID 1, node ID 2, node ID 3 maybe, or as many devices. If any one of them are alive, it will simply now do a mutual authentication. So the same mutual authentication procedure which we have discussed in the initial lectures is executed between them. Once that is done, A will just transfer the whole mail and all attachments to that particular node. Now there is also an issue because the mail should be synchronized across this. I will come back to that thing slightly later. Okay, so the mail is done. But suppose if none of these nodes are alive, then what is going to happen? Okay, so in that case, now A has to figure out a place where to dump the mail. And remember, A will put the mail there. For example, if this is going to be the root of hash of B at the rate whatever is the email ID, email domain, copy 1. So there are also going to be copies which are going to be maintained here. In fact, this actually is not required because I am not storing any key value pair. Okay. So what it is going to do is, only the reason why we do it, copy 1 and copy 2, because mail can be copied at 2 places. So A will search for this. A will also search for root of hash of B's email ID. This is the domain name again. Copy 2. So there will be 2 nodes which will become available to him. So what A will do is, A will now send a message, whatever mail which was to be sent to B will be sent to these 2 root nodes. So this will be also storing it and these will also be storing it. Okay. The moment B will come alive, it will pick up the message from one of them, but it will also then inform the other guy, which will also purge that particular message. B is having the message now. The reason for doing is duplication is if this guy dies off, so they are actually essentially doing this backup of messages to each other. So messages are always available. It's not that this guy dies off, B comes at that time and B can't find out the message. There is automatically a resilience being created by this looping. So we are recurrently using this particular mechanism of copy 1 and copy 2 to provide resilience everywhere in all DHT layers. Okay. So including, you can actually submit the attachment here. So that's going to be the best way of doing it. In fact, we can do it in another way. If I don't have to digitally, I don't have to encrypt an attachment. It's a kind of, for example, I want to send a movie to you, I don't want to encrypt it. In that case, I need not actually send it this way. I can actually push that thing into my file storage. So there is a file storage which we had talked about earlier. So there I have talked about UFS, Universal File System. So where the contents hash is going to be the key and the content will be there. So it can be for movie. So in fact there is going to be a descriptor file, not directly, there is going to be a descriptor file. And the hash of this is what is going to be used for looking for it. So whatever is the hash value of this descriptor file, I will actually generate a copy 1 and copy 2 will be appended and hash will be generated. Those will be the root nodes. So this descriptor, hash to descriptor mapping will be kept at those 2 nodes. Again, similar mechanism. So once you want to find out, you go there, get a descriptor file which will contain now the list of all fragments which are there and the hash value of each fragment. So you can just add copy 1 and copy 2 and then compute the hash of this and find out in the file storage DHT the root node where that copy 1 copy 2 goes, and from there you can actually fetch this key value pairs. You can fetch everything and create the whole file. So this has been discussed earlier. So this is what can be done. So you can simply, while sending email, can send the descriptor for this and say you have to search it in UFS. So the receiver B can actually search in UFS and fetch the whole file and all the fragments and can assemble the file back. You don't have to store the whole file, but anyway, even if you have to store few things here, but you cannot actually put in kind of movies kind of thing in few GBs, the whole file. They are actually going it this way is far better because you are doing fragmentation, so it's not loading any one particular thing. Okay. Only problem is if you are actually encrypting this so that the other person can retrieve it, you have to give a timeline on this. So after this is going to be purged because this is encrypted. If nobody accesses it, it's anyways going to be dead. Okay. So it will not be a perpetual thing. It will be having a final bit in that case with a timer associated with that. So within that, we will retrieve this whole thing and we will decrypt it. Okay, you can encrypt each one of them either with a key, which then can be sent to A in encrypted mode, can be sent to B from A in encrypted mode, and we can use that key to decrypt all this stuff. So that's another way of doing it. Okay. So once this actually files are being received, important thing is that the issue which remains is how to synchronize files across these multiple devices. Now for this, what is done is each one of these devices has the user's certificate. So these devices can actually access the same file system. Okay, in the storage DHT. So this file system is rooted at the user actually. This is not the node dependent, it's a user ID, which is the email ID / whatever it is. Okay, so I can now create here a mailbox directory. So whenever one node gets it, it will actually update, it will actually have a cached entry for its file system. So everybody has that cached entry. So it will first of all update in that cached entry, which in turn will get updated into this DFS. So automatically this is available to every client. So when I am going to look at the mail thing, I will actually fetch the same mail from this DFS or the user cloud system of the storage. So in every device you will be seeing the same mail actually coming up. So that's how it is actually going to be maintained. Okay, now regarding the issue how the message is going to be encrypted, that actually is another issue. So normally how the mail will be encrypted so that the intermediary in the mail storage DHT, no node should be able to decipher it. So what we do is, we know that I need to send to somebody like b at iitk.ac.in, I want to send a mail ID, I want to send a mail. So I actually will go into the base layer. Base layer also contains all certificates. All users certificates will also be stored in base layer. So you can get any user public certificate from base layer. Okay, again there will be copy 1, copy 2. So I will do copy 1, copy 2 and I will get the certificate from there. So user ID to the node ID mapping and user ID to certificate mapping is also stored. So I can actually get this user certificate. Once I have that, I have the public key of this user. So what A will do is, A will now get the whole message. Okay, so it will be message which will be there. It will create the message. It will actually find out if in UFS it has actually done the encrypted file being pushed. Okay, all fragments are encrypted, so that key will also be there. Key which has been used in UFS, which will be present here for attachments. Okay, so it will basically, when it will say key, it will give the hash ID, content hash by which the search has to be done. And once you get the content hash, the receiver B will be able to search it. It will then get all the things and it will decrypt using this. Okay, and similarly, if this is going to be for that, it can now also do the decryption key for the attachments. So in fact, I should actually keep it, I should re-explain it. Key in the UFS here actually means the key by which you do the search, which is the content hash. This for an unencrypted system. If there is an encryption which has been done, so there is a decryption key, which is basically if it is symmetric key, the key is same key has to be put here. So you can have multiple attachments for each one of them. You are going to prepare this actually. So once this whole message is there with you, you will now encrypt this. You will do encryption with the key. This is another key by which encryption is done. This encryption key, and this encryption key is actually appended. This same key is put here, and this is going to be encrypted with the public key of B. Okay. So the A is going to create this particular message. Now important thing is this message when actually is being put with node C. So node C will not be able to decipher what's there inside. It only knows there is a message. That's it. Okay. And the message will also contain only information that this is for B at the rate something is only for this. Okay, this has to be indexed with this actually so that B can retrieve this message. So A will just simply dispatch it, but then B also has to verify that this guy, who is the sender. So this message will have all that information, who is the sender and everything. So it need to verify. So we will sign this whole thing by the public key of A. Private key of A. There is going to be digital signatures. In fact, what can happen is even you can also put who is the sender. That information can also be told to node C. So whenever B is going to retrieve this, node C can send a message back to A that this message has been retrieved by B. So that's a kind of an acknowledgement will come to A. A will know that yes, now message has been retrieved by B. He will be able to see the message actually now. And by verifying with public certificate, A's certificate can be retrieved by B by looking at the sender here. And he can actually from their public key of A, it can verify whether this message is indeed not been tampered with. So if the message has been correctly received, the message is okay and it can open it up and it can read. So message, that's the way the messages will actually pass from one to another. And nobody will be able to figure out in between that what is the content of that particular message. And similarly, not only this message has to be signed. If the attachments are in UFS, whatever you are going to put in UFS should not have been tampered with, though that also need to be digitally signed. Okay, and normally you are going to retrieve that attachment and put it back in your mailbox in your DFS system. So you don't need to actually put it in UFS for a perpetual thing or for an infinite time. In fact, there is nothing like infinite, there is only perpetual flag. So whereby the timer kept on getting reset if you access the file. If you don't access it for a certain period, then it gets burst. So that's how the mailing system actually operates. So the next issue is how we are going to have the implementation of a list server. So how the list server is going to be implemented. So I will talk about in a brief video, which will be the next one in this same series. So as of now, we close at this point, and let's look at the next video for figuring out how the list server works.